Ohm's law. Voltage equals IR. That's a simple statement of Ohm's law. If I have a resistor R in units of ohms, and I push a current I through it, the voltage difference from one side of the resistor to the other, the voltage will drop. So if I measure the voltage from here to this point, I measure the voltage from here to this point. From here to this point, that voltage will be zero. There's no drop in an electric circuit diagram in a wire. They're considered perfect wires, perfect conductors. But from here to here, there is a voltage drop, and that voltage drop is positive on the side of the resistor that the current pushes through, and negative on the other side. And that voltage drop, according to Ohm's law, will be given by IR with the polarities chosen. So if I pick current going the other direction, if I pick current going this way, then the voltage that I use for Ohm's law has to be drawn this way so that the current is going into the positive terminal and out of the negative terminal. I'll make that I2R, make that I1R, just for clarity. Now, I should say that I just assigned a current in both of these cases. I don't know what's connected over here, and it might turn out the current goes in the opposite direction, in which case I1 would be negative. Voltage is a scalar. It's either positive or negative, depending on whether current is positive or negative. So if I pick this current going this way, then I have to pick the voltage being plus and minus here. But if I find out that my circuit, the solution to my circuit is the current's actually going the other direction, this current will be negative, and this will be negative, and the voltage will be negative, which means the voltage, if I were to measure it, would really be the reverse of this. It would be plus on this side and minus on this side. These are just assignments. They're not solutions. These are variable assignments, not solutions. And they are directionally dependent. So that's Ohm's law. Let's talk about Kirchhoff's voltage law. If I have a power source, it could be a battery, it could be anything. I usually draw the terminals, minus and plus, and then draw the current coming out of it. And I draw it coming out of a positive terminal of any source. It doesn't mean that there isn't another voltage source here, and it doesn't mean that this current couldn't be negative. If there's just resistors, this current will be in this direction. And for all power supplies, I usually draw the current coming out of the positive terminal, even if there's another voltage source over here. And then when I solve the circuit, it might be that one voltage source might actually be absorbing power. But this is how you draw a voltage source supplying power. And so I make that assumption, and then I solve the circuit equations to see if that assumption is true. So remember, from Ohm's law, I said the voltage due to a current going this way through the resistor produces a voltage here. Kirchhoff's voltage law says that the sum of the drops around a closed loop equals zero. And so what does that mean? What that means is if I take the sum of the voltage drops around a closed loop equals zero. Sum voltage drops equals zero. That also is the same as saying the sum of the voltage rises. It doesn't mean that some of these drops aren't negative. So look here, I've got a source, and so we're going to use as a convention in this class that if we go into them, Basically we're going to say that I'm always going to go around the loop clockwise. I don't have to. You don't have to. But I prefer that you always go around clockwise because it makes your problem easier to check. And so if I go into a minus terminal, I'm always going to write that as a minus Vs. And then if I go into a positive terminal, I'm going to write that as a positive Vr. And that equals 0. And what that really means is that Vs equals Vr. And if you do the algebra, you move this over to this side, then flip around, Vs equals Vr. So the voltage across the resistor is the same as the source. This is a pretty simple circuit. But for this circuit, Kirchhoff's law applies. Okay. Kirchhoff's current law.